Close your eyes for a moment and imagine the farthest thing you can possibly think of, a distant galaxy, a dying star billions of light years away. Now imagine stretching a ruler across the universe to measure the gap between you and that object. It feels obvious, doesn't it? Space is empty. Objects are separated, and distance is real. That's what every instinct in your body tells you. But what if your instincts are completely wrong? What if the universe is not made of objects sitting inside empty space at all? What if distance is not a fundamental feature of reality, but a kind of illusion created by the way information moves through the cosmos? And what if, at the deepest level, everything in the universe is far more connected than we ever imagined? Tonight, we are going to take apart one of the oldest assumptions in human history. Not with science fiction, not with philosophy, but with real physics. Ideas so strange and so powerful that even the greatest scientists struggled to accept them because modern physics has revealed something deeply unsettling. Space bends. Time stretches. Particles communicate in ways that seem to ignore separation. Galaxies move apart because space itself expands. And the deeper we look into reality, the less solid the idea of distance becomes. By the end of this journey, you may never look at the night sky the same way again. You may realize that the universe is not a giant, empty box filled with isolated things, but something much stranger, a hidden network of relationships where separation itself may not truly exist. And once you understand that, everything you thought you knew about reality begins to change. People think distance is one of the most obvious things in existence. You point at two objects, measure the gap between them, and say, that is how far apart they are. It feels undeniable. A city is far from another city. The moon is far from Earth. A galaxy is unimaginably far away. But modern physics quietly whispers something deeply disturbing. Distance may not be a fundamental property of reality at all. It may be more like a useful illusion created by the limits of how information moves through the universe. The human brain evolved to survive on Earth, not to understand the cosmos. Our instincts are built around ordinary experiences. When you walk across a room, you feel distance directly. Your muscles move, time passes, and your eyes confirm the separation. So naturally, we imagine the universe as a giant empty container filled with objects separated by measurable gaps. But the deeper scientists looked into reality, the stranger this assumption became. The first crack in the idea came when physicists realized space and time cannot actually be separated. They form one unified structure called spacetime. Spacetime. This means distance is tangled together with time itself. Something that appears far away in space may not be far away in time, and something separated in time changes how we measure space. The universe stopped behaving like a giant stage and started behaving like flexible fabric. Einstein completely shattered the old idea of fixed distance. Before his work, people imagined space as rigid and absolute. 1 meter was 1 meter everywhere in the universe. But according to relativity, measurements depend on motion and gravity. Two observers moving differently through space-time can disagree about distances and both still be correct. That sounds impossible because our brains want one objective answer. Yet nature does not care about our intuition. Imagine two astronauts traveling near the speed of light. As their speed increases, something astonishing happens. Distances in the direction of travel shrink. Not metaphorically, physically, the universe literally compresses from their perspective. A journey that looks impossibly long to us may appear dramatically shorter to them. The faster they move, the smaller the distance becomes. This creates one of the strangest consequences in physics. A star that appears 4 light years away from Earth may not appear 4 light years away to travelers moving near light speed. The universe reshapes itself depending on how you move through it. Distance stops being a universal truth and becomes something flexible. Even more shocking is the fact that you never actually see anything now. Light takes time to travel. When you look at the sun, you see it as it was about 8 minutes ago. When you look at distant galaxies, you are seeing ancient history. Some stars visible in the night sky may already be dead. Your entire experience of the universe is built from delayed information arriving at your eyes. That means what you call distance is deeply connected to communication delay. If information traveled infinitely fast, the universe would feel radically different. Separation itself might almost disappear. The reason distant objects feel distant is because signals take time to arrive. Think about this carefully. Suppose the speed of light were instantaneous. You could see every galaxy in the exact present moment. There would be no waiting, no cosmic delay, no visual past. The universe would feel less divided. Distance would lose part of its meaning because the delay that creates separation would vanish. This is why some physicists suspect distance is not fundamental. It may emerge from relationships between events and information, rather than existing as an independent thing. Then quantum mechanics made everything even stranger. Quantum entanglement revealed that particles can become mysteriously linked. When two particles are entangled, measuring one instantly influences the state of the other, no matter how far apart they are. Einstein hated this idea. He called it spooky action at a distance, because according to ordinary intuition, distance should weaken connections. If two things are separated by enormous space, interaction should take time. Yet entanglement suggests the universe does not always obey this rule. Imagine separating two entangled particles across opposite sides of the galaxy. Somehow their quantum relationship survives. The universe behaves as though separation is not fully real at the deepest level. Now, physicists still debate what entanglement truly means because it does not allow faster than light communication in the normal sense. But the philosophical implications are enormous. Reality underneath spacetime may be fundamentally interconnected. Some modern theories even suggest spacetime itself emerges from entanglement. In other words, the geometry of the universe may arise from invisible informational connections between quantum systems. Distance could literally be a secondary effect rather than the foundation of reality. Gravity deepens the mystery even more. According to general relativity, gravity is not really a force pulling objects through space. Massive objects bend spacetime itself. This idea is so strange that many people hear it for years without truly absorbing its meaning. Earth is not simply pulling the moon with an invisible rope. Earth changes the geometry around it. Objects move along curves in warped spacetime. If spacetime bends, then distance bends too. Near a black hole, the distortion becomes extreme. Space stretches, time slows. An outside observer and someone near the black hole disagree dramatically about measurements. The closer you get to the event horizon, the more bizarre reality becomes. At a certain point, ordinary ideas of distance nearly collapse entirely. From far away, an object falling into a black hole appears to slow down and freeze near the horizon. From the falling object's perspective, it continues inward normally. Two realities coexist depending on perspective. This means distance is not a simple universal grid. It changes according to energy, motion, and gravity. The universe behaves more like a dynamic living geometry than an empty container. Then cosmology introduced another astonishing revelation. Cosmic expansion showed that galaxies are not simply flying through static space. Space itself is expanding. This is one of the hardest ideas for people to visualize because our brains instinctively imagine explosions happening inside space. But the Big Bang was not an explosion into emptiness. Space itself expanded everywhere at once. Imagine dots drawn on the surface of a balloon. As the balloon inflates, the dots move apart not because they crawl across the rubber, but because the rubber itself stretches. Galaxies separate in a similar way. This changes the meaning of distance entirely. The gap between galaxies is not merely empty nothingness. The structure of spacetime itself evolves. Even stranger, very distant galaxies can recede faster than light because it is space expanding, not objects traveling locally through space. That sounds like it violates relativity, but it does not. The rules become subtle and strange on cosmic scales. The observable universe is already about 93 billion light-years across, even though the universe is only about 13.8 billion years old. At first, this sounds impossible. But it happens because space expanded while light traveled. Again, the ordinary human idea of distance completely breaks down. Then we reach the quantum world beneath space-time itself. Quantum foam suggests that at unimaginably tiny scales, space-time may not be smooth at all. People usually picture space as continuous, like an infinite flat sheet extending forever. But quantum physics hints that this smoothness may be an illusion created by scale. If you zoom into matter, eventually solid objects dissolve into atoms. Zoom further, and atoms dissolve into particles and probability waves. Reality becomes less concrete the deeper you look. Some physicists think spacetime behaves similarly. At incredibly tiny scales, called the Planck scale, space may fluctuate violently. Tiny wormholes may appear and vanish. Geometry itself may bubble and churn unpredictably. The calm, smooth universe you experience could merely be an averaged-out illusion, just as a wooden table appears solid, even though it is mostly empty atomic space. This creates a breathtaking possibility. Distance may not fundamentally exist below a certain scale. Space itself could emerge from deeper quantum processes we barely understand. Imagine a video game world. Characters inside the game think locations are real places, but underneath the graphics lies code and information. Distance inside the game emerges from computational rules. Some physicists wonder whether our universe behaves similarly, not literally as a computer simulation necessarily, but as an informational structure where geometry emerges from deeper relationships. The terrifying and beautiful implication is that reality may be far less physical than we assume. Even everyday experience quietly hints at this strangeness. Consider touch. You believe your hand touches objects directly. But atoms never truly collide in the classical sense. Electromagnetic forces repel electrons before direct contact occurs. What feels like touching is actually interaction through force fields. The world already behaves less solid and less spatially straightforward than intuition suggests. Or think about the night sky. When you stare at distant stars, your mind imagines points scattered across enormous darkness, but every point is a time machine. You are seeing layers of history simultaneously. Some light began its journey before humans existed, some before Earth even formed complex life. The universe you perceive is not a snapshot of one moment. It is a collage assembled from different times. Distance and time are fused so deeply that separating them becomes almost meaningless. And perhaps the strangest idea of all is this: there may be no universal now. Relativity suggests observers moving differently can disagree about which events happen simultaneously. Two people traveling at different speeds literally slice space-time differently. So if there is no single universal present moment, then the universe is not evolving through one shared cosmic clock. Reality becomes observer-dependent. Once again, the ordinary concept of distance dissolves because distance depends on simultaneity, and simultaneity itself becomes relative. This is why modern physics feels so unsettling. It does not merely add strange facts onto ordinary reality. It attacks the foundations of ordinary intuition itself. Your brain wants space to be fixed, solid, and absolute. Physics says it stretches, bends, fluctuates, and may even emerge from something deeper. Your brain wants distant things to be truly separate. Quantum mechanics hints that deep connections ignore ordinary separation. Your brain imagines the universe as objects sitting inside emptiness. Relativity suggests spacetime itself is dynamic and alive with geometry, and the deeper science goes, the more reality begins to resemble relationships, information, and structure, rather than solid things separated by fixed distances. Perhaps distances like temperature. Temperature feels fundamental to us, but at deeper levels it emerges from microscopic particle motion. In the same way, space may emerge from hidden quantum relationships underneath reality. If that idea is true, then one day physicists may discover that the enormous cosmos, with all its galaxies and black holes, is built from something where distance no longer exists at all. And that possibility changes everything humans thought they understood about reality itself. And so, after everything we've explored tonight, we arrive at a conclusion that feels almost impossible to accept. The universe is not what our senses told us it was. Space is not an empty stage. Distance is not fixed. Separation may not even be fundamentally real. For thousands of years, humanity believed reality was simple. Objects exist here, other objects exist there, and space is merely the gap between them. But modern physics has pulled away that comforting illusion. It has shown us a universe where time and space merge together, where gravity bends geometry itself, where quantum particles remain mysteriously connected across unimaginable distances, and where the cosmos expands not into space, but through the expansion of space itself. The deeper we look, the more reality begins to resemble a hidden web of relationships rather than isolated things drifting through emptiness. And maybe that is the most beautiful lesson of all. Because every time science destroys one of our old certainties, it does not make the universe smaller. It makes it infinitely more fascinating. Mystery is not the enemy of knowledge. Mystery is the beginning of discovery. The moment we realize reality is stranger than we imagined is the moment curiosity truly comes alive. Perhaps one day humanity will finally understand what space really is. Perhaps we will discover that distance emerges from something deeper, something beyond our current imagination. And when that day comes, the universe may look even more astonishing than it does now. Until then, keep questioning the obvious. Keep doubting easy answers. Keep looking beyond appearances, because the greatest truths in science are often hidden behind the things we think are most certain. Thank you so much for watching and being part of this journey through the mysteries of the cosmos. I truly hope this video changed the way you think about reality, even if only for a moment. Good luck on your own journey of curiosity and discovery, and never stop asking the questions that make the universe come alive.